Welcome dear students. In our last lecture we have discussed about one state of matter change, that was the change of solid to liquid, and that phenomena, as you know, is known as melting or fusion, right? Now in this term, in this video, we'll discuss about another process, the process of conversion of a liquid to a gas. But before discussing about this interconversion, let's think about some very common fundamental terms which appear to be quite similar, but they are not exactly similar. So first difference here which we discuss here is about gas and vapor. So is there any difference between a gas and vapor? Apparently it looks as if the two are same, but they are not same. Gas is the substance which is naturally in gaseous state at room temperature. If something at room temperature itself is in gaseous state, should be considered as gas. For example, you can talk about hydrogen gas, you can talk about oxygen gas, you can talk about carbon dioxide gas, because these are the substances that we find them to be in gaseous state at room temperature. And then what are liquids? Liquids, you can say, if it is the gaseous state of a substance which itself is liquid at room temperature. If something at room temperature itself is liquid, but by heating we convert it to the gaseous state, then it is known as vapor. For example, we have water in liquid state, and by heating we convert water to gaseous state. Now this gaseous state of water is known as vapor. So we call it water vapor. If it is the gaseous form of alcohol, then it will be known as alcohol vapor. If it is ether, then it is ether vapor, and so on, right? And there is another term, that is evaporation and vaporization. So if I ask you what is evaporation, you will tell me, of course, it is conversion of a liquid to vapor state. And if I ask you what is vaporization, of course, you will again tell me, it is what? It is conversion of liquid to vapor state. If both is same, if both is involving conversion of liquid to vapor state, so can we say that evaporation and vaporization are same? Of course, they are not same. Then what is the difference? Evaporation is conversion of liquid to vapor at any temperature below its boiling point. If a liquid is getting converted to vapor state at any temperature below its boiling point, then it is known as evaporation. Then what is vaporization? It is conversion of liquid to vapor state at its boiling point, right? So when a liquid is getting converted to vapor state at its boiling point, then the process known as vaporization. Now there is another question, what is then boiling point? So let's see what is boiling point. If I ask you what is boiling point, of course you will say the temperature at which a liquid starts boiling is known as boiling point. So boiling point means the temperature at which a liquid starts boiling at, of course, atmospheric pressure. Then that temperature will be known as boiling point. Now the question is, what is boiling? When we say that a liquid is boiling, so if I ask, then you will tell me that the process of conversion of liquid to vapor state is known as boiling. No, it's not boiling. Because liquid can be converted to vapor at any temperature. You have seen either by the process of evaporation or by the process of vaporization. Then the two cannot be same. So how we define boiling? For that, let's look at some liquid kept in a closed container at room temperature. Then what happens? Because of evaporation, some of the liquid starts getting converted to vapor, and now this process is known as evaporation. And when sufficient amount of vapor has been formed, then these vapors start getting condensed to give you the liquid form, and now that process is known as condensation. And a time comes when the extent of evaporation is equal to extent of condensation. And at this condition, the liquid vapors exert some pressure on the surface of liquid, and that is known as vapor pressure. So in order to understand what is boiling, first you should know what is boiling. And this boiling is associated to vapor pressure. So vapor pressure is the pressure exerted by liquid vapors on the surface of liquid when the process of evaporation and condensation are occurring at equal rate. And this vapor pressure of the liquid is directly proportional to temperature. As we keep on increasing the temperature, the vapor pressure also increases. And a time comes when we say that vapor pressure of the liquid becomes equal to atmospheric pressure. Now we say that the liquid is boiling. So boiling is that specific condition of the liquid when the vapor pressure of the liquid is equal to the atmospheric pressure. And the temperature at which this vapor pressure becomes equal to atmospheric pressure, then we say that this temperature is its boiling point. So liquid can be converted to vapor at any temperature, right? But the vapor pressure of the liquid becomes equal to atmospheric pressure only at certain temperature, and that certain temperature of the liquid is known as its boiling point, right? And again you see that all the liquids do not have equal boiling points. Some liquids have low boiling points, whereas other liquids have higher boiling point. So why is it so? Again, it is because of difference in their interparticle force of attractions. So stronger are the interparticle force of attraction, higher are the boiling point. Weaker are the interparticle force of attraction, lower are the boiling point. The liquids with low boiling points are known as volatile liquids, whereas the liquids with higher boiling points are known as non-volatile liquids. Volatile liquids means the liquids that are having weaker interparticle force of attractions and can be easily converted from liquid to vapor states, right? So, let's have an activity to study what happens when we start heating a liquid. Suppose we take a beaker and containing some water in it. Now put the beaker on a tripod stand, and with the help of a stand, you hang here a thermometer. The thermometer should be hanged in such a way so that the bulb of thermometer is not dipped in the surface of this liquid or water, whatever you have taken. And there should be a stirrer which ensures the constant stirring, and that makes the uniform heating of the water, right? And now put a burner, and with the help of burner you start heating the water. What happens initially, you observe as we keep on heating, the temperature of water also increases. But as soon as the water starts boiling, we do not observe any change in the temperature of this water, right? So why is it so? Where is that heat going? Of course, that heat is being used up in breaking down the interparticle force of attraction. So as you have seen in case of solids, you have seen latent heat of fusion. Similarly, he can call here as latent heat of vaporization. As you know, latent means hidden. The heat which is not visible to us in the form of increase in temperature will be known as latent heat of vaporization. So it is defined as the amount of heat required to convert 1 kilogram of liquid to vapor state at its boiling point at atmospheric pressure is known as latent heat of vaporization. So stronger are the interparticle force of attraction, higher is the boiling point, higher is the latent heat of vaporization. So if you have, say, liquid water at 100 degrees Celsius, and if you have steam at 100 degrees Celsius, which will give you more severe burns? Of course, the steam gives more severe burns than that of the liquid water. Reason? Because steam gives more amount of heat energy to our water, to our body in the form of latent heat of vaporization. It contains more energy, so it gives more energy to our body, and that's why it gives you a severe heating effect or burns as compared to that of water at 100 degree Celsius, although the temperatures of the two are same, right? And one more thing, that temperature of any substance is generally expressed in two terms, either in degree Celsius or in Kelvin. So what is the relationship between Kelvin and degree Celsius temperature? That direct relationship, that Kelvin temperature is 273.15 plus degree Celsius temperature. Exact relationship is 273.15, which we round off for our sake of convenience of calculation. We make it as 273 plus degree Celsius. So if we look at the freezing point of water, it is 0 degree Celsius or 273 Kelvin, and boiling point of water is what? It is 100 degrees Celsius or 373 Kelvin, right? So that was another idea about the state of change of matter. And in next lecture, we'll be discussing about one more very important phenomena, that is evaporation in detail. That evaporation has got number of very interesting effects and consequences in our daily life. So have a nice time and goodbye till then.